Hello, good morning or good afternoon, and welcome to our live webinar here today at Reliant Plasma. I'm very pleased to present you our series start PiezoBrush PZ3-i, the compact plasma integration as industry standard of the future. My name is Simona Lerdach. I'm the head of sales and marketing here at Reliant Plasma, and together with my great team here today, I'm pleased to introduce you our new product, the functions, and the customer references. Today, my members and the guides for you during the webinar will be Isabel Dölfs. She's our application technology expert, and Florian Hoppenthaler. He's our head of design and production and product manager. Now, our hidden stars today, and I hope you will learn them together afterwards, are our customers. We will start it with GeSiM. They will present us a compact plasma integration in multi-materials 3D printing, presented by Julian Schroll and Maximilian Richter. Followed by Keyence, Isabel will show you the plasma pretreatment in marking printing of PTFE fabrics. Followed by Frencken, she will show you different bonding applications in the PCB sector and a comparison with other plasma solutions. The video will be presented by Pierre Smith and Wouter Buntoff. At least, I'm very proud to present you our partner, igus. Jens Kerner will show you in a live demonstration how easy is the integration of our plasma unit in robotic system. Now, before we get started, some advices for you. The webinar will be recorded and will be made available to you so that you can share it with others and watch it again. During the time, all listeners are muted. If you have questions, so please use the question box on your chat panel. I hope that we will be able to answer all your questions in the following Q&A session. Now, I hope that all of you know who Reliant Plasma are, how long we existed, and if yesterday my daughter asked me, Mom, is your company hip? Are you on social media? And I said, yes, but let's have a look on our company history. Already in 2002, Reliant Plasma was 100% daughter by the Rennhausen Plasma GmbH. In 2006, we were able to launch our first plasma brush series and based on the technology pulse atmospheric arc. Followed in 2009 with our handheld device series PiezoBrush, based on the technology piezo dielectric discharge. In 2014, we split it off from the mother concern Rennhausen, and we became new shareholder Dr. Stefan Nettesheim and Klaus Forster. Also, we were renamed under Reliant Plasma. In 2018, we became 100% daughter of the DTK Group. During all the time, we tried to establish our management system during the industry standard ISO 9001 and in 2020 during the medical device regulation to the standard of medical devices. Now, I'm very happy that we are able to launch our new product PiezoBrush PZ3-i and that we have already customers which are in use of them, and Isabel will show you now first a short insight about our technology, plasma technology, and then she will introduce you our customer references. I wish you a nice session and see you soon.
Yes, welcome also from my side, ladies and gentlemen. Thanks to Simona for the kind introduction. And of course, the biggest thank goes out to you for attending our webinar today. So before we get started, let's have a really short recap on the effect of plasma on surfaces, or more precisely on the surface energy. So if we place a drop of liquids on a surface, it will most likely contract, building a round sphere. And this you can see on the left side. You can also observe this at home by just applying a drop of water on your Teflon pan, and the drop will not wet the pan surface. So this is actually due to the low surface energy of most plastic surfaces, and by plasma treatment, for example, with our PiezoBrush PZ3-i, something happens to the surface which is invisible to the human's eye. So basically, you can see already on the right side, the drop that is applied now will be more flat, so it will be more likely to spread over the surface and wet the surface. This again indicates a high surface energy and a stronger bonding between the surface and the liquid. Of course, this wettability not only depends on the surface, but also on the liquid. So also for printing inks or adhesive, this is also the case. Yeah, but what exactly has bonding to do with adhesion or wettability to do with adhesion or bonding? So to answer this, let's have a look on the molecular structure. So for bonding process, only the uppermost layers are significant here. You can see on the left side that on the surface there are no binding sites available, and by plasma treatment you can see that there are kind of anchors groups created that can form a bonding to the polar groups in a liquid. As already mentioned, these functional groups are mostly polar, so they can interact with the liquid. But there are also surfaces that already have quite a high surface energy by nature, for example, metals, and still wetting or printing on them is still quite difficult. So this is because of contaminants on the surface that inhibit the bonding sites on the surface. And you can see it here on the left side. This can be due to prior processing that lubricants or release agents or also coolants are inhibiting those bonding sites. This is the second important effect of plasma, and yeah, you can see here that plasma can fine clean the surface by removing this very thin layer. So much about the theory. To give you a more practical feeling about surface energy, we collected some plastics here in this chart. You can see that the surface energy splits up into two parts. One is the dispersed part and one is the polar part. You can also observe here the trends that by plasma treatment, mainly the polar part increases. Also, you can see here quite a special candidate in the chart. It's PTFE. I already mentioned the PTFE pan in your kitchen. You can see here that without plasma activation, it is basically inert. And I'm really happy that today our beta tester, Keyence, will show how successful they were with PTFE fabrics. So that was it from my side. If you wish for more information about plasma technology, sorry, we're live, please visit our website where you will find comprehensive information about plasma technology itself, and of course also about our products. So now I wish you a lot of fun with Florian's demonstration, and please keep in mind to ask your question in the question box, and see you later when it comes to the beta test report.
Thank you very much, Isabel and Simona, for your introduction. Hello, everybody. My name is Florian Hoppenthaler, and today I like to give you some information about the newest product of us, the PiezoBrush PZ3-i. So some of you already might know our PiezoBrush PZ3 handheld device, and both devices are based on the TDK Saraplast technology. So because of that, the new product, the PZ3-i, is completely compatible with all the PiezoBrush PZ3 modules, those available and the upcoming ones as well. This is the integration version of the handheld device. So even though the overall design is very different, the internal electronics and the modules are identical. So this means there is no technology gap between those devices. And this is very interesting for example, the development. If you start working with the handheld device and switch over then in your production line to the integration version, so you can transfer all the validated parameters to this device. There are no high voltage cables required due to its design. It is a robust, modular, compact and lightweight design to make the integration as easy and solid for you as possible. The device has a very low power consumption of under 18 watt. It has a very low thermal stress on the substrate. So this might come in handy for you because there is, for example, no warping on thin polymer parts. There is no surface damaging due to high temperatures. The device works with relatively low flow rates of either compressed dry air or nitrogen. We're in a range of 8 to 20 standard liters per minute. On the device itself, you have a visualization via status LEDs you can see up here. So on the device itself, you can see the status of it. But of course, with the communication cable, you also have the possibility of an external control of the device with digital I/O signals. For example, the plasma OK signal as a feedback signal to have more process safety or process control. For the future, there is an additional bus communication schedule. Unfortunately, it's 2022, and as you might know, the availability of many electronic components is quite difficult. This already caused some delays on the development. I think you might have experienced that as well. We're very happy that we now have a working device and that it's available from shelf, but the additional bus functionality will take about until the end of this year. Let's have a look at the scope of delivery. What is included? It is the device itself, of course, which is separated into the module carrier and the driver unit. It comes along with one connection cable in between those two units. There is a set of mounting screws and a seal sticker included, as well, even though not depicted, a operating manual. Not included is the power supply, because since in the case of the integration version, the integration will be very different depending on your machinery, on your processes, and you might even use only one or several devices in your process. Also, the gas hose, the connection cable for the power supply and for the communication are not included, since this as well might be very different in your applications. The modules are not included because for your application, you have to please just order the module that you need for your process. Even though the connection cables and the gas hose can be ordered as additional equipment, and we'll just come back to that in a few seconds. On the left-hand side, the technical data overview. Don't be afraid, we will not be going through that completely, but there is just some rough information. So the weight of it is only 370 grams to make it easy to adopt it into robots or maybe gantry systems. The dimensions are smaller and more compact compared to the PZ2. And you even have some possibilities how to arrange the components that we will see as well. And there are a few more components of the device I'd like to show you or to name them for a better understanding of the rest. On top of the driver unit, you have a config port here. We'll come back to that later. The locating pins, we will speak about them, as well as the adjustment screw on the module carrier and this white locking ring where the module is inserted. As I said, the scope of delivery is what you see here in the center of this picture. You will need to order one module per device at least. Please choose for your application which module you need, or contact us if you're not absolutely sure which module will be the right for your application. You can order the connection line set. This consists of a gas hose, 4 mm outer diameter, so very standard gas hose, and the connection lines. Each of those three components has a length of 10 meters, but as I said, in your application, in your machinery, you might require much shorter or longer cables, and feel free to order them directly because we stick to an industrial standard, which is the M8 connectors. You find the specification for all those cables in the user's manual. They come with the M8 side on the device and with open wires on the other end to connect them to your machinery or to your PLC. And this is the power supply connecting line, and according to that, the communication line with the same M8 connector system. Next is an overview of the schematic overall structure. So what I described by now is here in the center, the PiezoBrush PZ3-i. Here you see the schematic plasma discharge over your substrate. This is what it's all about. There is something being plasma treated with this device. And what you need to set up in your machinery additionally to have a working system is a gas supply and a gas control system like a mass flow meter or a mass flow controller. You need a 24-volt power supply, which is connected with the DC cable, and you need something to then turn on and off your plasma as desired, which can be a PLC or a simple switch or maybe a photoelectric sensor. This will be very strongly dependent on your application. The device can either be mounted on, for example, a robot, a gantry, or it can be mounted fixed over a conveyor belt or over a manual substrate manipulator. With this mounting, you can also realize the heat conduction of the device. It's actually very low heat that is occurring, but you should know if you have a conductive material, for example, an aluminum base plate or something, that supports the heat conduction away from the device. What's very important to know is that whenever you produce plasma in atmospheric conditions, due to the oxygen that is in the air, there will be ozone, some amount of ozone, and you need to make sure to get rid of that with a gas extraction with sufficient extraction power. What we recommend is to control and overview the gas extraction and the gas supply, so the mass flow meter, for example, in your PLC, and to only activate the plasma start option if those two parameters are okay. As I said, there are three typical integration situations that we shown here as an example, which is a static mounting of the device, in this case 4 devices to increase the treatment width. This can be for a manual movement of the substrate or over a conveyor belt system. Maybe one of the most common applications is the use in a linear robot or a gantry with 2 or 3 degrees of freedom. It's a very typical solution for dispensing applications, for example. With a dispenser just next to the plasma generator, you can just duplicate your movements with a little offset, and you can pre-treat and then dispense your glue. And for very complex shapes and with the 6 degrees of freedom, it's of course also possible to use a PZ3-i in a robot system. Now let's have a closer look at the basic functions. We start with the connections. We already had some information about them. So here we look at the top of the PZ3-i. You can see the driver unit and the module carrier here. We have one connection on both that is connected with the included 0.3 meter connecting line. Next to this, we have the DC in and the communications in. Up here is a interface for the earth potential. And on the driver unit, you can see the LED status, which is green for plasma, yellow for warning, and red for error. On the module carrier, you have a gas interface here, as I said, for the 4mm gas hose. It's a very simple, quick connector with just push in, and it's installed very easily. Next is the assembly options. The standard assembly option is, as shown down right, if the module carrier is mounted on the driver unit. For the assembly, the only tool you will need is a 2.5mm Allen key screwdriver. And we show the mounting here in a video for you to have a closer look. I can just in the same time install it here live. As you saw in the scope of delivery, there is a mounting screw set included. Please start with the shorter one of the 3 screws and insert them in the top center. And with it, you can already fix the driver unit on your base plate. I recommend to not tighten this screw already, because this makes it easier to find the right angle for the other 2 screws. And with those installed, you can also tighten this screw. The next thing you will need is the module that you choose for your process. In this case, the module standard. Please remove it from the little box and insert it into the module carrier. Make sure that the locking ring is unlocked, which is indicated by red color and a unlock symbol. The module cannot be inserted incorrectly, so it will slide in just easily. Then lock it by just turning the ring until you see the green and locked symbols. On the back of the module carrier, there are two holes that will just snap fit onto the driver unit. You can hear and feel the module carrier clicking onto that. You can then install the gas hose on the module carrier by just pushing in the hose into the quick connector and then make sure that it sits in firmly. All the upcoming connectors are, as I said, M8 connectors that you can fix just by hand. They're all coded, so there is actually no way to plug them in incorrectly. Just make sure that these small indicators show in the right direction before you push them in, and then just tighten them by hand. It's the same procedure for the DC line and for the communications line. Of course, you then need to do your wiring on your PLC to make all your connections. And the only thing still necessary here is the ground potential that is installed here, as you can see in the video. But then you're already installed your device completely. You then have some settings that you can do on your device by loosening the adjustment screw here. By loosening just slightly, you can adjust the height to get the perfect distance to your substrate. By loosening it more, you can also adjust the angle of the module carrier, as you can see in the video. There are some pre-adjustments you can see. These are special angles that we will see on another slide. And once you then fix this module carrier in the perfect situation for your process, we recommend to use the included seal sticker, because for the maintenance, for the module change, there is no the screw anymore. And to avoid anybody accidentally interfering with your process parameter, it might be best to just seal this screw. In some cases, with not very much space in your machinery, it might be interesting to use other mounting settings. So what you can do is you can mount the module carriers off the driver unit. To do so, just remove the locating pins from the driver unit with the 2.5 Allen key and insert them to a prepared drilling, boring that is also explained in the user's manual. And once you installed the locating pins, you can then again just snap your module carrier into this position until it's fixed. All the other installation steps are, of course, the same. So here again, you see the assembly option that I showed you if they're mounted separately. What you should know is that the included connection line between the two units is 0.3 meters. It's possible to use longer cables in between, even though it's a strong influence into the EMC. This means if you want to use longer cables, you maybe need to check in your integration situation if there are any EMC problems, because the increased cable length then makes it strongly different how your cable is installed in your machinery. So it is possible to increase the distance, but maybe it might cause EMC problems in your machine that you should check in advance. What you can also see here is that the modules can be mounted next to each other. The width of one module is 40 millimeters, and this is also the minimum distance of two Seraplas next to each other to work properly without interfering anyhow negatively with each other. So you can just mount them shoulder by shoulder to increase your treatment width. And if you have very high requests for homogeneity of your plasma activation, it might be necessary to also install devices on a half stack in between back to back with the first row, so to fill up the gaps between the plasma discharges in one treatment direction. The communication options of the PZ3-i are the switching signals in the first release version that we have ready here now. You have switching signals on a 24-volt level. The input to the device is the plasma on signal that starts or stops the plasma production. And this signal can be up to 24 volt. Between 10 and 24 volt, you always use the 100% plasma power. And if you go below 10 volt down to 3 volt, you can adjust the plasma power as shown in the table. Below 3 volt, there will be no plasma discharge. Even though most applications will not really need a lower plasma power, since, as I said before, we have very little thermal stress on the substrates, and it's very unlikely to overtreat or damage your substrate with our device. On the device itself, you have the LED indicators. They show the status of the device. So you can see plasma discharge, you can see if the device is ready, or you can see with some flashing signals of the yellow warning, which kind of error or warning is active now. Please make sure, as I said before, that your plasma on signal can only be activated if you have sufficient gas supply and sufficient extraction power. And the plasma on signal can only be interpreted correctly if it occurs no sooner than 100 milliseconds after the connection of the 24-volt power supply. This means if you switch on the power supply and the plasma on signal simultaneously, the device will not recognize the plasma on signal. So please always make sure to first supply your device with power, and then only switch the plasma on signal on and off to start and stop the device. And only after maybe your process is stopped completely, then only remove the power supply itself. Here's just a short video about the LED codes. You can see now a yellow and red flashing. That means there is no module inserted. The device is not ready. With the insertion, it switches to green and yellow switching code. That means ready. Green is plasma activation. It's now stopped again. And now we force an error by bringing something electrical conductive to the module for non-conductive material, and you see the device goes into the error mode with a blinking code, and then it's resetted by removing the power supply and setting it back up. In some cases, it might be necessary to switch the error mode. This might be for materials as compound materials, for example, CFK carbon fibers, something like that, that are not clearly non-conductive or conductive. To do so, please just open the config port and switch the dip switch number 7 on the position. All the other dip switches are not necessary to anyhow change by now. This is later for the CAN bus functionality. But if there is a material that cannot be treated properly, it might be good to change the error mode from failure to warning. So the tolerance until the device stops and goes into error mode will be longer or bigger. As I said, about for the turn of the year, we plan to have the bus communication available. It will be a CAN open digital bus communication. This will have some benefits for you as well. The installation will be easier because compared to the digital I/O setters by now, where you need a 24-volt and digital I/O cable for every device, you can then use short connecting cables for the communication signal from one device to the next one. All devices will have own addresses. They can be then addressed one by one or all together over your PLC. You will also have much more process details for each device. By now, you get a plasma OK feedback signal. With the bus communication, you will also be able to get voltage, current, operating hours, and so on for every device. You will have detailed error codes on your feedback signals, and the error acknowledgement will also be able via the communications cable. The module change is very easy and very fast. In the shown situation where there is not enough space under the device to completely pull out the module, you can just remove the module carrier without any tools. You can unlock it, remove your module, insert a new one, turn the locking ring back to the locked position, and push it on in the same position as it was before. So this is just a matter of a few seconds, and even faster if you have a situation as here, if there is enough space, or if you use it in a robot or a gantry and you're in home position and there is enough space below, it's only unlocking, removing, setting in a new module, and locking it back, and you're good to go. So it's really very fast maintenance. The modules that you might already know because they're already released since a while is the module standard for the treatment of non-conductive materials such as plastics, glass, ceramic, paper, and natural fibers, and the module near field for the treatment of electrical conductive materials like metal, carbon fiber composites, doped semiconductors, or wood. What you should know is that this device only works properly if there is a conductive material in front. Otherwise, the device will give an error signal because it thinks that it's maybe a wrong plasma situation. The upcoming modules that will be released very shortly are the 3 needle modules: the module needle, the module near field needle, and the multi-gas module. The upper 2 are like just the shown before for non-conductive and for conductive materials. With the needle electrode, you have the benefit of a very fine plasma discharge, and due to its length, you can also go into hard to reach areas such as gaps or holes. Same for the near field needle for conductive materials. And with the multi-gas module, you have the possibility to insert a technical gas like argon or helium and use some plasma chemistry that is not possible with CDA or nitrogen on special materials or special requests. We already saw the adjustment options for the module in the video. So as I said, you can adjust the height if you loosen the adjustment screw slightly, and you know the seal sticker, I showed that before as well. And the angle adjustment of the module carrier might be maybe a little difficult to understand if you didn't work with the device already. The footprint of the Ceraplus is a bit of a rectangular shaped, and if you have high requirements in the homogeneity of your plasma treatment, then it might be interested to use this angle adjustment, because you can then either decide with a 45-degree angle to have the maximum treatment width in both rectangular directions by best homogeneity, or with the other angles you can use the maximum intensity at best homogeneity. If you have questions about that, you can just contact us to get further information. But this will be only important if you have very high requests for homogeneity. The process gases that you can use through the device is CDA and nitrogen. Both, of course, have benefits and drawbacks. CDA's availability is, of course, very high. It's cheaper. So very often this is what our customers use. But you should know that with nitrogen, as you can see in this picture, you have the much higher treatment or activation area. And as shown down here, this is maybe about the standard size or footprint with the use of CDA, which will be about 20 millimeters. And this is with nitrogen. So if you have applications with a large treatment area, it might be interesting for you to think about using nitrogen. The performance of the device is, on the one hand side, described by the system availability. Due to the fast, tool-free replacement of the low maintenance interchangeable modules, you have a high system availability. With one channel, it is 99.9%, and even with 5 channels in a row or 5 devices in a row, you have 99.97% system availability. The mean time to failure of the modules themselves for the standard module is 3,000 hours, and for the near field module 2,000 hours. And what might be very interesting for you, after buying the device, the operating costs per hour are very low compared to a classical plasma jet system due to the low power and gas consumption. Compared to this, in this case, maybe our PB3 system, you have only about the 1/8 of the operating costs per hour compared to a classical atmospheric plasma generator. There, of course, are other benefits, such as the lower weight, the lower size, and the lower heat transfer to the substrate. So here, compared to our PB3 system, but of course, other plasma generators, atmospheric plasma generators, are about with similar data. To make your integration as easy as possible, we provide all the connection information, the specifications for the cables required, a 3D file, step file for your CAD planning, and you have the measurements to prepare all your mounting plates and installation information, for example, to not have any conductive material as cables or metal nearby the plasma end of the PZ3-i, to avoid a side discharge of the module, because this might, on the one hand side, decrease your activation power, and over time it might also damage your module. Some of you might have already seen this slide because it's exactly the same from 2020 when we released the PZ3 handheld device. Before developing the new PZ3 system, we had a customer survey, and we looked very close to our wishes, our ideas, our requests of our customers. And already in 2020, we showed you what we solved with the PZ3, with the handheld device, with the upcoming modules. But what was still left open were some requests, and we told you in 2020 those will be solved with the PZ3-i. And now it's 2022, and the automatic version with the 3-axis desktop robot, or the continuous operation with power supply, the externally controllable function, as well as the active feedback signal and the housing with flat walls, all that went into the PZ3-i. And we really hope that we met your requests, your wishes, maybe even exceeded them. And I really want to thank all of our customers and our beta testers for communicating with us, for telling us your wishes, your requests, your needs, because we really hear that, and we really enjoy the close work together to develop products that are good for you, that solve your problems. And we really want to continue this way, because we feel that it's a very good way. And it's the third webinar now, and we'll sit here and watch the upcoming results of the beta testers. And it's really a great joy for us to see what now is achieved with this device, that other companies now have further developments, or they solve problems they had much easier. And we really enjoy that, seeing that the work together is going in a good direction. So thank you very much for all your ideas, even all the critics, everything, all your feedback is very good. And please stay in touch with us, with your questions, with your ideas, and we will do our best for the future to develop more and more improvements for these products. There will even be an ongoing survey about the PZ3-i, so it will be online in a short time. And if you have any ideas or any feedback for us, you can use this platform. So the overall summary: PZ3-i is easy to maintain. It's a modular system that you can just scale to your treatment width or to your desires. You have a communication and process safety, work safety, and a very easy integration. It's environmental friendly due to its low consumption, and since you can replace maybe some primer applications with critical chemicals. You have a very good price-performance ratio, a low threshold process validation, since you can just transfer your handheld device results to the process directly, and you have a very low thermal load on your substrates. So thank you very much for your interest into our new device. I will now hand over back to Isabel and to the results of the beta testers.
Thank you very much, Florian, for this great and also interesting demonstration of our PiezoBrush PZ3-i. We just saw how many advantages and benefits the PZ3 actually has, and to prove some of them to you, we invited some of our beta testers today. And at this point, a huge thank you for helping us with your feedback and improving our serial product. So we start with GeSiM. GeSiM is a special machine manufacturer from Saxony, close to Dresden, and is your partner for hardware solutions for top-notch research and also commercial industry. So I am really pleased to welcome now Julian Schroll and Maximilian Richter from GeSiM to show how easy it actually was to integrate our PZ3 in multi-material 3D printing. Thank you so much.
So, hello. Thank you for the introduction. My name is Julian. I'm from marketing and service, and my colleague here, Max Richter, from R&D, which is primarily responsible for testing the PZ3-i. To most of you, we're probably unknown. We are a small specialized machine manufacturer from Saxony, from Dresden, in Germany. Ever since 1995, we develop specialized solutions for science, for researchers, but also for the industry. And we are a very small team of engineers and researchers, and therefore we are quite often involved in common research, joint research projects, and also we do a lot of custom tool development, which we later on integrate onto our robotic platforms. The company started with microfluidics in silicon wafers, microfluidic structures, from which they developed pipettes for micro and nanoliter dispensing, which then got integrated into a pipetting robot, which finally went into the creation of our multi-material 3D printer, which is also the tool we integrated and tested the PZ3-i on. This is the printer. It's called the bioscaffolder of the 5th generation. It's developed for printing biological material and tissue, and multi-materials at the same time. It might not be obvious, but it has 4 individual tool axes, 4 Z-axes, and we installed very easily the PZ3-i on one of them and connected it with our SPS, which the whole system drives already. So for us, it's quite interesting to modify the print surface to well, you know what I mean, to make it more hydrophile, and then coat it with either 3D printed hydrogels or with liquids such as growth factors, etc. We tested the PZ3-i on a flat surface, a surface with cavities, and a surface with spikes to see how it would perform with different three-dimensional target surfaces to simulate how the plasma would penetrate into these cavities, and which would give us a better understanding on how well it could be integrated into our 3D printed structures. It, besides the hydrophilization aspect of it, it is also quite interesting for us because we can offer our customers a sterilizing tool with which they can integrate into a hybrid print between cells and biomaterials, and then the potential sterilization. So we also, as I in the introduction mentioned, have a lot of microfluidics. So it's also very interesting for us to use it in that field. There's a short clip also how we treated a microfluidic chip to change the fluid behavior of it. So now I'm going to play the video, and don't get confused. In the second part of the video, we show the pre-successor of the plasma tool from RelyOn, simply because we could better show it how to integrate it into a multi-material process from a previous project. The liquid you see is just colorized water. Here it's a microscopic clip. That's the microfluidic chip with the, we used both the tips. We used the close field and the standard tip of the PZ3-i. Here the cavities are treated. And you can see how at one time it filled the cavity, and the other time the droplet basically just stayed on top because of the surface structure, surface tension. And here again after the plasma treatment. So that's the second part which I mentioned. Here it's also quite interesting, maybe for our partner Keyence, because we also integrated their tool in this multi-stage process to analyze the thickness of a printed layer, basically. All right. Well, that's about it from us. From our side, it was very pleasurable to work with RelyOn, and the PZ3-i showed very easy integration onto our system. And yeah, and again, thank you for the opportunity to speak here.
Thank you, Julian, for this really nice video material. It's really nice to see that the PZ3-i worked so well for you and the application. So our next beta tester, I feel really honored to present by myself. So it's Keyence. Keyence was founded back in 1974 and is one of the world market leaders in the fields of automation and quality assurance. So thanks goes out to Tobias Tondera. He's the area product sales manager and team leader at Keyence. And you may remember at the very beginning when I was talking about the PTFE use case that we will see now. So Keyence was basically using their continuous inkjet printer, the MKG 1000, which can also be used for applications in the food, chemical, and cosmetic industry, but also in the electronics, automotive, and metal industry. Here you can see a picture of it, and yes. So what Keyence was testing for us was basically they were investigating how PTFE fabric or also glass can be labeled reliably and also effectively. So they used our PiezoBrush PZ3-i with their continuous inkjet in order to get abrasion-resistant label printing. This is how the process looks or looked like. So they put the plasma device, the PZ3-i, directly before the inkjet printer on the right side. And so they had therefore a quite fast process. They did not wait until the printing, which is also suggested by us. And they also mentioned that the setup of the PZ3-i was quite user-friendly and easy to do, as only power supply and CDA supply was necessary. Now let's come to the printing results. So in the upper row, you can hopefully clearly see that the printing or the labeling is not that readable as in the row below. The data matrix codes cannot be scanned, and also abrasion tests did not show the targeted result. With the plasma treatment, we see a clear picture of the DMC code, and it was also abrasion resistant. So what was the conclusion of Keyence? So they mentioned that due to the plasma pre-treatment, the label printing on the PTFE fabrics was possible without there were the problems that the DMC code wasn't readable. And they also mentioned that due to the plasma pre-treatment, traceability can be ensured. Also, they emphasize the user-friendliness that we also provide you a handheld device, our PZ3, which can be used for live demonstrations. So thanks to you, Keyence, and everyone who was involved in this project and for these valuable insights. So now we come to Frencken. Frencken is a global integrated technology company for one-stop solutions for the medical, semiconductor, and analytical industries, as well as factory automation sectors. So many thanks to Pierre Smits and Wouter Bunthoff for your valuable results and application report. You did not only proved the bonding application with temperature-sensitive semiconductors, but you also compared our PZ3-Is to alternative plasma devices. Thank you very much for that.
Welcome everybody at the webinar. Next to me is my colleague Wouter Bunthoff. Hello. He will present later on. I'm going to start taking you with us with our experiences. We're from Frencken Mechatronics in the Netherlands, in Eindhoven, and we're going to share our experiences using the PZ3-i beta test device. And we would like to thank Relion to select us to be one of the beta testers. On the agenda, we have for you today the PZ3-i in our production, and we're going to share our experiences during the use of the beta test device. We did a surface tension test, some lab shear tests, and I'm going to share our future plans that we have for the PZ3-i. And from here on, Wouter will take it over for me.
Hello, I'm going to explain why we want to use the PZ3-i in our company. One of our customers recommended using conventional hot plasma. Hot plasma is a high energetic plume. This puts a lot of energy in the part, also resulting in a temperature increase. However, we assemble magnets. Magnetic properties degrade at certain temperatures. This temperature starts around 45 degrees. This is easily achieved as seen in the table, especially with delicate tin parts. For example, you can see a burnt mark on a magnet from hot plasma on the picture on the right with the circle. Plastics are also at risk as seen in the pictures in the middle. The PZ3-i has no visible deformation on the surface, but the hot plasma pan has melted the plastic, which resulted in the visible deformation. Around half a second, and each interval it increased with half a second. Our experiences. Currently we use the PZ3 in production. It's an easy to use device for low volume batches because you can easily turn it on and start plasma cleaning. We used it already as a risk mitigation for a filled bond. You can see the part on the right upper corner. It's an aluminium bracket with a thin steel shim. Due to some forces it came loose, but we didn't have any problems anymore after starting plasma cleaning. Currently we are also using the PZ3-i in the prototype phase. The first parts are ready for high volume cleaning. It's easy to use in combination with our glue robot. They are both 24-volt systems, which make it easy to integrate. However, we have mounted the module carrier separately because it has a lower weight and it's easier for the glue robot to maneuver around. The feedback signals from the driver unit are immediately passed to the glue robot and acts accordingly, so we can interrupt or stop the process if the plasma cleaning isn't sufficient or if an error occurs. Now I'm going to show you a video about the plasma cleaner on the glue robot. The glue robot uses an absolute coordinate system. This results in a programmable distance from nozzle to surface and a programmable speed. We can use the same program over again, which results in a controlled and repeatable process. Another benefit of this system is that after plasma cleaning, the next step of gluing can be performed immediately. You put the plasma cleaner up and you insert a syringe and run a slightly different program that applies the glue. This mitigates the risk of touching the surface and contaminating the surface. One of the tests we did is a surface tension test. One of our customers had requirements which indicated a maximum bonding window of 20 minutes after plasma cleaning. However, research showed that longer periods of enhanced surface properties are still present. If a significant decrease in contact angle is still visible, the bonding window can be extended according to the customer. The part is a nickel-plated stainless steel, which had general cleaning for use in an ISO 6 clean room. Afterwards, in the clean room, it's cleaned with acetone. The time of this test is directly after plasma cleaning. Left side of the orange line is plasma cleaned. The right side is only cleaned with acetone. The contact angle on the plasma cleaned side has decreased and is expected to have higher surface energy. This would mean that bonding strength will be improved. This will be tested in later slides. The time of this test is 15 minutes after plasma cleaning. A slight increase in contact angle can be noticed compared to the previous tests, but significantly lower than the non-treated side. This test is again after 30 minutes. It has a similar contact angle as with 15 minutes. This test is 45 minutes after plasma cleaning. Now a slight increase in contact angle can be noticed compared to the one from 30 minutes. The time of this test is 1 hour after plasma cleaning. The contact angle is still much lower than the non-plasma clean side. The contact angle is low enough to prove to our customer that surface properties are still enhanced enough to extend the bonding window up to 60 minutes. Another test we did is the lab shear test. We wanted to verify if plasma cleaning is beneficial for bonding. We did this by doing a lab shear test. A lab shear test is a destructive test by pulling out two bonded substrates vertically. The purpose of the test was to compare bonding strengths for different surface treatments. The glue we used is the DP460EG. This is a low outgassing vacuum compatible two-component epoxy. It's frequently used in semiconductor vacuum applications. The module used is a near field module because we use aluminum substrates to test. We had 4 variants. All variants were first cleaned with EPA, afterwards with acetone, and then the different steps came. We had a control group with no extra step, that's variant 1. We had one with a manual PZ3-i, that's variant 2, and we had one with the integration module, that's variant 3, and we had one with a conventional hot plasma pen, this is variant 4. Here is an example of a lab shear test. If you listen carefully, you can hear the glue cracking, and you can even notice it. Now you can see on your screen the 4 series with 2 samples each. You can see the different types of glue that is still present on the substrates. I will explain you something about different types of failures. There are 3 types of failures. I'm going to discuss 2 of them because only 2 of them apply. The left one is a cohesive failure. This is within the glue layer, and the glue is the weakest link. The right one is an adhesive failure. Adhesive glue remains on one side only, so a failure at the interface between the glue and the surface. Here's where plasma cleaning can improve the bond. Optimally, you want a cohesive failure because you maximize the strength of the glue. Okay. Now we look back again at the samples. The CD series have mostly a cohesive failure, which is the most optimal. When pulled apart, the glue cracked and remained on both of the surface at the same location. If you look at the A and B series, glue remains on one of the 2 substrates, but not both at the same location, and therefore an adhesive failure. Now we are going to look at the results. We put them in a clustered column diagram on the left. We did 6 measurements for each variant. For us, the minimum and the mean are the most important. Plasma cleaning results in a better controlled process than non-plasma cleaned, because the standard deviation is lower for them. The PZ3-i is comparable to the hot plasma pen and therefore can be used for temperature-sensitive materials. In the test, the PZ3 scored about the same values as the PZ3-i.
Thank you, Wouter, for your presentation. Currently, we're still using the automated plasma cleaner in the proto phase, but we want to roll it out across all our customers. We'd like to deliver reliable and long-lasting bonds. We'd like to share our knowledge with customers in the NPI phase to solve problems before they even arise in the volume phase. Currently, we're mainly gluing metal parts, but we also in the future would like to elaborate and we are planning to start investigating to use plasma cleaning for critical ultra clean parts. And last but not least, we plan to integrate the PZ3 into the automation process using cobots. Thank you all for your attention. We showed that the reliability of our bonds increased significantly by using plasma cleaning. The PZ3-i is an excellent option for Frencken mechatronics because of cold plasma generation and still the same performance compared to conventional hot plasma pen. We hope you enjoy the rest of the webinar. Thank you for watching us.
Yes, Wouter, Pierre, many thanks for your presentation and the comprehensive application report, and that you shared your experiences with us. So now we come to igus, to its robotic department. Learn now from Jens Klerner how easy it is to integrate the PiezoBrush PZ3-i with an industrial robot. Jens, the stage is yours.
Hi, my name is Jens. I work for igus here in Cologne, and I'm responsible for the Abitix marketplace. That's a low-cost robotics marketplace. We will take a look at the marketplace in just a moment, but first I would like to lay out what we're doing in this time slot. First, I'm going to show you how easy it is to configure your own robotic solution, including a PZ3-i end effector. And we will configure, let me take the webcam here, a robotic system just like this one. So here we have an XYZ gantry system, and of course the PZ3-i cold plasma end effector. So this we will do on the website, and second we will then program the robot so that you see that it's also really easy to get the robot up and running. We will do a sample program here. It's really easy. I will share my screen later, and then you can take a look at the easy program interface. All right, let's get started. I will just share my screen here. All right, so that's the Abitix marketplace. It's an open marketplace. We have over 70 partners right now, and Rely on Plasma is one of our partners. We're really happy that we can now offer cold plasma robotic solutions thanks to Rely on Plasma. You can build your own robot here. You can pick the robots, you can pick the end effectors, etc. We give 2 promises here on the marketplace. First, price transparency. That's true for all the 8 countries where we are currently active. So that's Germany, France, UK, Austria, United States, Canada, Singapore, and India. And the second promise we give here is the guaranteed compatibility in terms of hardware, software, and electric. That's really important when you want to combine components from different manufacturers, that the compatibility is guaranteed, and we do this with our configurator here. All right, so let's just build exactly the same robot system that I've just showed you. Let's filter here that we are only seeing our gantry systems. And where do we have it? Here that's the system, 400 by 400 by 150 millimeters. So as I said, you always see the prices, you see an overview of the product, some explanation videos. You can even customize the gantry systems to fit your needs. These systems can also be 2 or 3 meters wide and high in height. The download of the software is available here. The software is for free. So we always say test before invest. So you can download the software, play around with it, and just figure out if you get along with the software before you make any purchasing decision. Okay, so then let's add this gantry system to our configuration. So now we select an end effector, and here it is, the PZ3-i end effector. Of course, also with all the tech data and downloads that you need to get further understanding what the product can do for you. Let's add this to our configuration. So we have now the robot, we have the end effector, we have the controller for the robot, which is always part of the robot itself. You could add a vision system, services, software, etc. But for now, we have all we need. And now you see in your shopping cart website the robot that you've added, the end effector, and then we always then dynamically add components to make your robot complete. So in this case, we see the mounting plate, which is specific for this end effector and this robot flange, so that you as a customer, you get one package on one day where everything is inside, so that the robot is ready to run, so to speak. So you are not missing any parts or components to get it up and running. All right. I think then I will connect to the robot itself, and then we take a look at the software and do a sample program. So that's the igus robot control. That's the name of the software, and I just quickly connect with the robot. Let's click on connect, and we just download all the programs and settings from the robot so that I have it all on my computer now. All right, we just enable the motors, and there we go. Okay, what do you see here? You see the digital twin, as we say, of the robot system. You can move the robot or teach the robot, for instance, by just clicking on one of these axes and then just move it along. I will just take the webcam so that you can see that it actually moves. So here I just grab the axis and you see that it's moving. Another way how to teach the robot is by physically touching the robot. I will enable this mode here, and let me open a new program so that we can do a quick sample program. Let me grab the webcam. So I've just activated the manual teaching mode, so I can teach the robot by hand. I can move it up and down, I can move it left and right, I can pull it towards me or away, and just like this, let's do a little program. So let's say we want to start the plasma treatment here at this position. I have an empty robot program here, an empty canvas, so I just hit J for adding the position of all the joints. I will now click on Action Digital Output. That's where the PZ3-i is connected to. So the output is 34. Enable, and now I will move the robot to the side and hit J again, and then say Action Output 34. That's the plasma end effector disabled. And just like this, I will make it a little bit more compact so that you can see all the steps at once. Yep, here we go. And just like this, we did our very first program together. We go to position A, we activate the plasma anti-effector, then we move to position B, and then we deactivate the PZ3-i. And that's how you do a robot program. But of course, like a good TV cook, I prepared something. Let me show that. All right, it's exactly the same program that we've done. I've just added a couple of more positions in between. Okay, so let's deactivate the system here, enable the motors, and here we go. Let me grab the webcam again, so you can see that the robot is now doing the plasma treatment in a couple of rows. And you can also see the digital twin. And since I set the program on repeat, it's just repeating and doing the same motion again. All right. So we'll stop the robot here and switch back to the website. All right. So we're back on the RBTX marketplace. So in case, even though this is really easy to build your own robot with the Plasmaintegration, but in case you don't know which robot to pick, or maybe you want a different size, or you want to, want some answers, we offer a free consultation. You're just on the very first website, click here on book a free video call, and you just pick a day and the time, and you just enter there your name and email address, and then you get an email with a Microsoft Teams link, and then you can talk to one of our experts for free, describe the process that you would like to automate, and then we can help you find the right robot solution for your application. All right, that's about it. Thanks for listening. I hope I could convey that it's really easy to get started with robots and to build how easy it is to build a cold plasma robotic solution. And I'm very thankful, and thanks to all the folks at Rely on Plasma for having us here in the webinar. Have a nice day. Take care.
Yes, thank you so much, Jens, and greetings to Cologne. So that was it from our webinar. Now I am really excited to have our Q&A round. Simona, Florian, please come back and assist me with the questions, and a special thanks goes now to my marketing colleague, Christina Wimmer. She was quite busy during the webinar to collect all your questions and to cluster them. So the first question is, how long can the plasma treated parts be stored before further processing? So here you are addressing the so-called hydrophobic recovery. So this means how long does it take the surface to regain its original status. And this really depends mainly on 3 factors. The first is, of course, the plasma treatment itself, or the process method. For example, which process gas did you use, and what plasma system. The second one is the nature of the substrate, so which substrate did you use. And the third one is the storage conditions, like temperature and relative humidity. So generally, we suggest our customers to do further processing as fast as possible after plasma treatment.
How soon will the PiezoBrush PZ3-i arrive? After I order it, I hope soon. Normally, we need 2 to 3 working days. For larger sizes, from 10 pieces on, please have a quick chat with us. I think it's not much longer, but it's 2 to 3 working days.
Next question is, what treatment does it normally achieve? Also here we have quite different results depending mainly on the process gas. So for CDA we reach 5 to 29 millimeters approximately, of course, and with nitrogen 5 to 50 millimeters.
Can I also treat electronic components without hesitation? No, the treatment of electronic components with the PiezoBrush technology must be tested in advance. Due to its basic physical kind of plasma generation, there are high electric fields that can damage electronic components. For our PB3 system, for example, we have a special nozzle, the A250, with a low potential outlet. But for the PiezoBrush technology, this is not available. So if you want to treat electronic components, you must check if those are damaged by this discharge or not. Can I control all devices in a lineup solution together, or do I have to control each device individually? Well, both is possible. That depends quite much on your integration solution, on your PLC. So you can just turn them on and off simultaneously by connecting the plasma on signal to one switch, but you can also address them one by another. And of course, with the canvas functionality in the future from the upcoming year, this is possible as well, both to simultaneously or to separately address them.
At what speed does the plasma treatment take place? So this is also very depending on the application that you are following, and also on the substrates and other process parameters. So for fine cleaning, we are estimating around 1 to 50 millimeters per second. It really depends on the factors that I just mentioned. For adhesive bonding, we have speeds from 10 to 150 millimeters per second. And for printing, we reach even more. It's about 100 to 1,500 millimeters per second.
What is the purpose of changing the angle? I assume you mean the rotation angle of the module carrier. With the module standard or near field, when we have the direct discharge on the Serra Plus component, there is a, well, kind of rectangular footprint because the discharge is strongest in the 4 corners. And if you go straight in that or that direction, then there will be not a optimum homogeneity of the plasma treatment. And by rotating it, you can align the 4 corners in the one or other direction to have a equidistant position in this direction, which evens out the plasma treatment over the treatment width.
Now we are coming to the end. We would like to say thank you for joining our webinar. And at this point, we would like to encourage you, if you have great results and references with our PiezoBrush PZ3-i, please do not hesitate to go into contact with us. Maybe we can share that information with customers, or you can attend on our next webinar. We are always looking for new application cases to show what is possible in the field of plasma. Thank you very much. I wish you a nice afternoon. Have a nice day. Goodbye.